Alright, welcome back to 6.1. Let's look at some of the questions that are going to be here as we go into the homework. They want us to just have a better understanding of inverse cosines, inverse sines, inverse tangents, just the inverse functions in general. So remember, this is going to be core, and so they're not going to get too big on us right away. But we should be able to understand and make adjustments in our understanding. So they want us to consider the cosine function defined by the inverse cosine function defined by y equals cosine inverse of x. Is this function increasing or decreasing? So let's remember what this function's doing. This function is taking numbers between -1 and 1 and mapping to angles between 0 and pi. So let's try some things. Let's take a look at the function itself. So its mapping, its domain is from -1 to 1. So here's -1, and we'll put 1 way out here. Its range is between 0 and pi. So what about at -1? So what is the cosine inverse of -1? What value do we have? Well, we have pi. That's the angle, right? 3 point something at pi, right? So I apologize, I'll put pi out there. But we're way up here. We're up at pi. So at -1/2, the cosine inverse of -1/2 is 2 pi divided by 3. It's less than pi, so we're coming down. And at 0, what is it? What's the cosine inverse of 0? What angle do we take the cosine of between 0 and pi and get 0? Pi over 2. So now it's down here at pi over 2, and it's coming all the way down to 0. It's more of a curve, but it's looking something like that, coming all the way down to the 0 there. There'll be a better pictures, but it's decreasing for sure, because the cosine inverse of 1 is equal to 0. You know that. This means that the cosine of 0 is 1. And so we're having to think in reverse, which is really good. Let me get rid of all this little chicken scratch and we can focus on this better problem. So again, these are all designed to help us understand. Arc cosine of -1/2 is 2 pi over 3. Why is it not -4 pi over 3? Well, why are they asking that question? Because where is -4 pi over 3? Let's find it. -4 pi over 3 is going this way, -pi, but then pi over 3 more. And that's the exact same terminal side as 2 pi over 3. This is why they're asking the question. Why is it not equal to that? Because somebody would say, well, then the cosine of -4 pi over 3 is also going to be -1/2. That angle is there. It's because what arc cosine is asking for is what is the angle between 0 and pi whose cosine is -1/2. And -4 pi over 3 isn't in that interval. The arc cosine can't spit that out, otherwise it wouldn't be a function. And so it is simply because 2 pi over 3 is the only time it happens in that domain. It's a one-for-one function. Number 11 is wanting to know, is secant inverse A calculated as cosine inverse of 1 over A or as 1 over cosine inverse of A? Well, let's find out. Secant inverse of A is equal, let's just make up a letter. I'm going to make up a letter W. Let's call it W. That means secant of W is equal to A. That means cosine of W is equal to 1 over A. That means cosine inverse of 1 over a is equal to w. So it's this first one. So you can figure out the secant inverse of a value by inverting it and talking about the cosine inverse. There may have been a better way to explain that, or a different way, I'm sure, right? So, because what is this a? A is the number that comes out when secant's applied to the angle. Well, that's the flip of what cosine would be. So obviously you'd flip the a and not the whole value. So we need to get really quick at evaluating these. So this is 14 to 36 even, right? So this is what you're going to be doing in the homework. Sine inverse of -1. I have to think about what angle do I take the sine of to get -1? And that is minus pi over 2. I cannot say 3 pi over 2 because it's not in the angle. I have to represent that. So I could be thinking, oh, it's this angle right down here. Let me do that in a different color. It's this angle where sine's -1. I have no option but to express that as minus pi over 2, since sine's output has to be between negative pi over 2 and pi over 2. How about arctan of -1? Well, here's what I would think to myself. Oh, I know it's a pi over 4 angle. It's either tangent corresponds to sine because that's what's on top. Sine's output is between minus pi over 2 to pi over 2, so it's a negative. But I would start with the reference angle. Here with cosine inverse of -1/2. I'd ask myself, cosine of what value is 1/2? And I'd instantly say pi over 3. Then I'd ask myself, could it be that first quadrant angle? No, because of the negative sign. So I have to ask myself, is cosine spitting out in quadrants 1 and 4 or 1 and 2? And I remember that cosine spits out between 0 and pi, or 1 and 2. So it can't be this first quadrant angle. It can't be this angle because negative pi over 3 is in quadrant 4. It's got to be 2 pi over 3, as was mentioned twice earlier. Arc cotan of -3. I don't think well in terms of arc cotans. So I'm going to do arctangent of -√3 over 3. So I think to myself, okay, what tangent is the √3 over 3? Is it maybe pi over 6? Let me think about that. Sine of pi over 6 is 1/2. Cosine of pi over 6 is √3 over 2. So that'd be 1/2 times, yep, that's my guy. It's a pi over 6 if I go through my memorization stuff. Now the question is, where does tangent end up? In quadrant 1 or in quadrant 4? And the answer is is it between minus pi over 2 and pi over 2, or 0 and pi? And it's between minus pi over 2 and pi over 2, so it's going to be a negative pi over 6. Okay, so secant of -1/2. I would look at this, or -√2. I would look at this as cosine inverse of -√2 over 2, because that's the flip of √2. I know that this is a pi over 4 angle, and it must be in the second quadrant, so it's 3 pi over 4. Cosecant, well, that's the same as arc. Cosecant flipped is sine of -2. And the answer here is there's no solution. There is no angle that you can take the sine of and get -2. So they're going to throw those in there. These weren't made up. And then how about this one? Arc sine of -√3 over 2. I know that that's a pi over 3 reference angle. I know that sine's bound between minus pi over 2 to pi over 2. So I know I just have to represent that as the negative. Notice all of these are negative because if we do the positive, they're in the first quadrant. Arc cosecant of -2. Well, that would be the arc sine of -1/2. Well, that's a pi over 6 reference angle in the fourth quadrant, or negative pi over 6. That's how fast we want it. If you have avoided memorizing, this will be a very long section for you. And your future classes will be very difficult. So let's take a look at these last ones. Tangent inverse of √3. Okay, tangents like sine, so it's going to produce answers between minus pi over 2 and pi over 2. It's going to be a first quadrant angle because it's positive, and to have the root 3 up top, that must be a pi over 3 angle, because when the root 3 was on the bottom before, I needed to have a pi over 6 angle. So there's my answer, pi over 3. Regardless of what I was in there. Cosine inverse of negative 2, can't happen. No solution. There is no, it's asking for the angle whose cosine is negative 2, doesn't exist. And so we have that type of leading problem there. Just looking whether I need to cut the video or keep going. Now we're getting into a little bit more thinking types of aspects. What's the sine of sine inverse of root 3 over 2? Well, the sine inverse of root 3 over 2 is the first quadrant angle whose sine is root 3 over 2. So it's kind of ridiculous, but you could do it this way. Sine inverse of root 3 over 2 is pi over 3. The first quadrant angle. Sine of pi over 3 is root 3 over 2. It's doing exactly what an inverse function should do, and that is cancel each other out. How about here? Sine inverse of sine of pi over 6. That's the sine inverse of 1/2. Sine inverse of 1/2 is absolutely pi over 6. It's doing what an inverse should do. How about here? Cosine inverse of root 3 over 2. That would be the cosine of pi over 6, pi over 6. And cosine of pi over 6 is root 3 over 2. So it did exactly what it should do. And then what about here? Cosine inverse of cosine of pi over 3. We will indeed get pi over 3. Now what about something like this? Sine of arc cosine of 1/4. Well, we don't know whose cosine is 1/4, so I can't name the angle. So what do I have to do? Realize that arc cosine of 1/4 would be a first quadrant angle, whose cosine, adjacent over hypotenuse, would be 1/4. So I need to solve for this guy in order to determine the sine of that angle, because essentially I'm not able to find that angle, but the sine of that angle would be, right now I know what the answer is, it's something over 4. Well, what is that something? Well, it's 1 squared plus y squared is equal to 4 squared, or y squared is equal to 15, or y is equal to root 15. So it's root 15 all over 4, and we're walking away. Something like this, cosine of 2 sine inverse of pi 1/4. Okay, well, what's that? We would need to use maybe a double angle formula to come up with something like this. So if you remind yourself of the double angle formulas, there were multiple for cosine. If we know that the sine of the angle is 1/4. So if I use this representation, cosine of 2a is equal to 1 minus sine squared of a, then here's what I have. I have this guy being equal to, oh shoot, sorry. Okay. Let me find out where we are here. I really apologize for that happening. Okay. Alright, we're almost there. It's right back up here. So there's some hefty lifting here, but 1 minus sine of 2a. Well, we know that sine of a is 1/4. It was given to us, and we square that. So this is 1 minus 1/16 or 15/16, and we don't have to go draw a triangle. And so that's what's happening as we go into these other areas right here. They're going to bring up our old formulas and stuff and see if they can throw us off. So it is a little bit lengthy as you go through here. So how are we going to do the tangent 2 of cosine inverse of 1/4? We're going to go remind ourselves that tangent of 2a. Let's go find that guy. Tangent of 2a is equal to 2 tan a all over 1 minus tangent squared a. Well, I don't know what tangent a is. I do know that cosine of a, though, is equal to 1/4, and that a is a first quadrant angle. And so we have the 1 and the 4, and so we're going to get the same root 15 out of that. So what's the tangent of a? Opposite root 15 over adjacent 1. So this is 2 root 15 all over 1 minus root 15 squared, or 2 root 15 all over 1 minus 15, or 2 root 15 all over 14, or root 15 all over 7. And we can do it that way. Now remember this cosine inverse of cosine, right? Here's the issue. If you cross these guys out, you end up with an angle that we don't have. So we have to really ask ourselves a question. Where is negative 5 pi over 3? Where's negative 5 pi over 3? Well, it's just close to negative 6 pi over 3. You know that this is going to be then a positive cosine value, and it's going to be a over 3 angle, and in the first quadrant the answer is simply just pi over 3. The cosine inverse of cosine of negative 5 pi over 3 is going to be pi over 3. If you didn't believe me, go work it out. Cosine of negative 5 pi over 3 from chapter 2 is going to be the cosine of pi over 3, because it's that reference angle, which is 1/2. The cosine inverse of 1/2 is the first quadrant angle, pi over 3. The last one on this page, and then we'll break the video up again. Cosine of sine inverse of 3/5 plus cosine inverse of 5/13. You can't distribute that cosine if you're thinking that. It's not a multiplier, it's a function. This is the sum of two angles. And so what is this? Cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. Now, cosine of sine inverse of 3/5, that's an angle in the first quadrant whose opposite over hypotenuse is 3/5. This is 4, so this is 4/5. Now cosine of cosine inverse of 5/13 is just going to be 5/13. This is going to be the angle that gives us 5/13, and if we took the cosine of it, we get 5/13. Minus sine of sine inverse of 3/5 is going to be 3/5. So when it's the trig function happening last, remember that has no restrictions on it. You don't have to worry about that at all. These will automatically undo one another. Sorry, sine of sine inverse of 3/5. So when it's the trig function on the outside and not the inverse function, where it's a lot better. And then 5/13. So the cosine is 5/13. So this was 5, this was 13. That would be 169 minus 25 for 144. So that's a 12. And this is 12/13. And then we go from there. I wouldn't cancel out those 5s because we're going to need that common denominator. 5 times 13 is 65 minus 36 over 65, which is going to be negative 16 over 65. And so I don't think that that's going to break down at all. Nope, not 5 or 13, but that's our answer, negative 16 over 65. So before I cut the video, let me talk to you about what I was trying to drive at um, with these problems. You can see the work that we're going to be doing in here. So again, it kind of messed up that work, but you have it there in the video. When you take the cosine of the cosine inverse of any number between 0 and 1, let's say 0.1234, the answer is simply 0.1234. There's no need to stress about that. They'll undo one another because the last thing you're doing has no restrictions. However, if you do the cosine inverse of the cosine of 7 pi over 4, then you have to pay attention because the last thing that you're doing has a restriction. It can only spit out between 0 and pi. So you have to think about 7 pi over 4 is not going to be an answer because it's not between 0 and pi. So it's not just a cancellation out of the two because of the restriction. So you definitely know it's a pi over 4 angle, and it's either pi over 4 or 3 pi over 4. Now how do we know which one? Think about 7 pi over 4. Where is it? Well, it's in quadrant 4. All students take calculus. Its cosine is positive. So it can't be 3 pi over 4 because its cosine's negative. It's the first quadrant angle of pi over 4. So think about that. And I apologize that I hit that side button again. But hopefully this will help you as you navigate through the homework. There's no substitute for experience. And we'll make a third video for this 6.1 exercise to keep things small.